So hello and welcome everyone to the this month's technical steering committee of the Linux Foundation Energy Project Everest. I have to show you this antitrust policy for a moment because there could be competitors in the meeting, and then we can dive into the actual presentation of Everest. This is our short agenda of the day. We will cover what Everest actually is and give a quick recap and introduction to it. If you know Everest already and you watch this this multiple times, or you watch it on or have watched it multiple times and now watch it on YouTube, you can skip to the next chapter if you know that already, because that's most of the times the same. Then we will talk about what's new and what's next, and then we can discuss community requests and features and lead or head over to an open discussion. So what is Everest? Everest is, of course, part of a bigger picture. Here you can see the ecosystem of the Linux Foundation Energy, which is a group of industry leaders which are creating software for the ecosystem for the green electricity grid. And Everest is the core component to the EV, so responsible for all the electric vehicle and charging infrastructure related components of that. So we are doing software for charging stations. So we have in the charging infrastructure and e-mobility a really complex and fragmented industry with multiple isolated solutions. We have a lot of different actors in this field. We have charging providers, utilities, payment providers, OEMs, and also charging station manufacturers. And basically all of them are implementing the same protocols that are around in this landscape. So we're talking about cloud communication from the charging station to the cloud for payment services, monitoring and service. And we're talking about communication to the electric vehicle using the protocols there. So everybody's doing the same thing, same software on every charger. And this is, of course, really cost and time intensive and really inefficient because like you have almost the same code on every charger. Every part of this software needs to be maintained. And it also leads to really poor customer experience because you have like all these different interpretations between different standards and protocols on the EV side, charger side, and cloud side. And that leads to the fact that charging oftentimes simply does not work. So what is Everest? It's like an operating system for your charging station. So it runs on a tiny embedded Linux device and is the core of your charging station. And it has implemented all the standards and protocols that are around in this ecosystem. So there's the OSPP protocol for cloud communication, and you have the ISO 15118, IEC 61851 for the communication to the car. And we have implementations for all of that, and also abstractions for this whole hardware layer of a charging station. So basically, every charging station is set up in a way that it is quite close to another one. So you can say that there are almost always identical components in the charger. So you have the RFID reader, you have the power meter. Of course, you have some control over your protocols, you have LEDs, displays, and all of that stuff, and we have abstractions for all of that. So it's really easy to exchange like hardware components because we have interfaces for all of that, and then you can simply like drop in another implementation or driver for your module, for example, for your power meter, and the other part of Everest is still the same. So it also connects multiple different services and devices. So it sits inside your charger, and it has like a lot of different requirements to fulfill. This is communication, of course, to the cloud. I talked about that, but you also need to talk to your home solar and battery system, to other consumers in your house or in your building, probably also to other chargers. You get signals from the electricity grid and from the cloud, of course, and all of that is covered in this system. So what do we do about that? We cannot fix this by adding more standards. There are already enough standards around, and we try to implement them. But we want to be a standard compliant open source implementation that serves as a de facto standard. So all these incompatibilities will go away, and we have like a really stable and reliable implementation of those standards with Everest. And so everyone can use it. It's free to use. It's open source, and not everyone has to implement it himself. We also have like a development kit available, which is a small AC charging station, which is quite powerful, with a Raspberry Pi compute module and a Powerline communication module, Alpha D reader, a lot of things to play around with. Also with a low-level board, our Yeti board, so you can actually use that charger and charge your car with it. And you can, so it is designed as a development kit, so you can play around with it with all the access that you need and all the options that you have with that. Of course, there's also more hardware available. Everest is already running on a lot of different platforms. To name a few, there is the ChargePoint, Charge Control C, where Everest runs on. We are running on boards from Fitech and CPUs from TI. We are supporting the Lumicil Powerline communication module, and there's a lot more to come and to show. This also summarizes like the whole ecosystem around Everest. I mentioned on the last slides already that of course, as a charging station, you need to fulfill a lot of requirements and get in touch with a lot of different players. And this is also represented on this slide. So we are talking or are participating in standardization bodies and working groups for defining and contributing to the standards and new standards and protocols that are around. We are working together with component suppliers for like CPUs, for PLC chips, for power meters, and stuff like that. Of course, we also work together with charging station manufacturers as a big or important part of Everest, and also with all these cloud services that are around there, so e-mobility providers and charge point operators. So what's new? The first thing I would like to highlight is that OSPP, that Everest now contains the server side of OSPP. So there are two repositories that are part of the Everest ecosystem right now. Those are mentioned below. This is the connector container and the connector serverless, which are basically implementations of OSPP on the server side. We can really need this within Everest for testing, and this opens up like the whole cloud side for Everest. And we are looking for companies and individuals who would like to contribute to this OSPP server side. We will need like to work out how we can actually use and include this, for example, for our testing purposes. But this is something that we will definitely do in the future. But Everest and also Pionix will like continue to focus on, of course, being backend agnostic and focus on the charging station side of things. For OSPP, we are mainly working on or like almost always working on the OSPP 2.0.1 implementation. There are a lot of big things that we want to do there. So we are currently refactoring the device model architecture to make it more flexible and to simplify it to add and remove new components and variables to support like any hardware platform or like charging station that is available. There might be one with a fan, there might be one with a power meter that has like more data available, or there might be RFID readers who can report different stuff. And we want to create an OSPP implementation for 2.0 that supports those different hardware approaches and hardware designs. And we want to be able to report this data and also to enable backend systems to control all of that. And for that, we need a really flexible and easy to use device model architecture. So this is like one of the key components of the design of the library of libOSPP. There was a minor pull request about a transaction started callback, which we didn't have because we didn't need it in Evros core so far. But now you can like actually call, or now a callback is called when like a transaction has actually started in order to report the transaction ID of that. And we have also continued with implementing OSPP 2.0.1 use cases like remote start and remote stop. So we try to get the basics ready, and then or we try to get the basics ready, like state machine, device model, and all of that stuff, to make it really easy to just go through the use cases that are there, so that we have like all the support available and can really go on with that. On ISO 15118, there's a few new stuff. We have started to change the high-level communication from our car simulator from RISE V2G to Joseph. So there's no support for simulating like cars with Joseph on the EV side. For this, there's a new PyEV Joseph module that has been created for that. And we have also extended the car simulator with ISO 15118-20 AC functionality, but this is an ongoing process and will need some more time to be completed. And what else we saw with all the refactoring is that we probably can find a better design of the car simulation in general, so that there will in the future will probably be something like an EV manager. Now we have an EVSE manager on the EVSE side, of course, and this controls like all the lower level protocols, and it contains the general charging logic and session management and all of that. And it's really nice to like exchange protocol stacks on this side, and we have like a really neat design there. And we want to do the same thing on the EV side for the car simulator. Right now, the car simulator module is like loaded with also simulation functionality, and we want to pull that out and move that to another module so that we have a cleaner separation between those modules. On the EVSE V2G module, so our ISO 15118 implementation of the ISO 15118 protocol, we have made some bug fixes, which were like a segfault when parsing the TLS certificate and key files, and improvements regarding the service list and the service discovery response, and also some minor changes to embed TLS. For the Evros framework, we have ongoing work on remote requirements, so that modules can not only require each other or provide functionality to each other when they run on the same host. We want Everest to be able to run on different controllers, so on different charge controllers, basically. And we still want the opportunity for them to communicate, so that we have the chance like to run the OSPP module, for example, only at one controller, but two controllers can use that module to communicate to the cloud. Also for NHB management, it's really a really nice solution that we can control multiple chargers that run on different controllers for energy management purposes, and also for authorization. That's really, really useful. And then we will do some new stuff around error handling inside Everest, which will touch the framework as well. So we will enhance the functionality there in a way that modules will be able to report and raise errors, and that other modules who are interested in that can subscribe to it and then use that to behave in certain ways, whatever they want to, basically. So there will be error handlers that will be called if you have subscribed to some certain error. For example, for OSPP, that's really useful just to report those errors. Some modules might want to behave differently, do different stuff, and we want to create support for this on the framework level, and I think that's a really good improvement. So the June release is mostly stabilization and bug fixes. It's not out yet, but will come out tomorrow or in the beginning of next week. We have had some big releases in the last months, and this month we mainly focused on stabilization. So what is next? There is the general roadmap, which you probably also already know, and I mentioned a lot of stuff already. So we are working on OSPP 2.0.1, C++ implementation of the ISO 15118-20, and an XC parser for that. And then on the roadmap more in the future for 2024, we want to implement Charlie Mode, GPT, want to work on our energy management, remote connections. I mentioned already, this is already happening right now, and some other protocols we want to implement. And of course, we continuously add like new driver modules to Everest for power meters, RFID readers, and all of that stuff. There are, of course, events coming up. The Embedded Open Source Summit in Prague is starting, already next week. There will be the Chaos Communication Camp from 15th to 19th of August, the ICNC in Berlin, organized by Hubject, the Drop Conference in Sweden and Malmö, another OSPP festival, and 2 Charan festivals coming up, one in the EU, which will be in October, and there will be one more in the US, but we do not know the date yet, but we will definitely be there. We would like to highlight the Chaos Communication Camp, where we will have a village around Everest and open source for EV charging infrastructure. It is in August. I think I mentioned that already, 15th August to 19th August in the Ziegeleit Park Mildenberg, close to Berlin, or in Berlin actually. We will bring a lot of people who work in the field of Everest. We also applied for a presentation around a small project where we use Everest, and we hope that this will get accepted. And then we will have a lot of fun there, doing hacking and coding and talking with people about EV charging. Next TSC will be the 27th of July, 2023. Of course, always feel free to join our public weekly technical Zinc, which is Tuesdays. The time changed. It was 10 to 11 before, but now it's 3 to 4 Central European time. Feel free to join. And now we will head over to the discussion. Thanks for joining.